By the end of this video, you'll be able to do fridge wiring by yourself. Compressor is the most important part of a refrigerator. Here, you can see a compressor. Inside it, there are 3 terminals: common terminal, start terminal, run terminal. To initiate the compressor, we use a relay. Why is this needed? Because initially the compressor needs extra support from the starting winding. The relay helps by supplying power to both the start and run windings. Once the compressor kicks in, the relay disconnects the starting winding. From there, the compressor continues running only on the running winding. To safeguard the compressor, an overload protector, OLP, is used. If the compressor overheats, the OLP cuts off the power supply. Once the unit cools down, the OLP automatically reconnects the power. Inside the fridge, there's a temperature control knob. This is a rotary thermostat. It lets you set your desired cooling level. When the internal temperature drops to the selected level, the thermostat disconnects power to the compressor by breaking the circuit. When you open the fridge door, a light turns on. This is managed by a door switch. When the door is shut, the switch is pressed, which turns the bulb off. When the door is open, the switch pops out, on, allowing power to flow to the bulb, lighting it up. The plug top connects the refrigerator to the electricity supply. The right pin of the plug carries the phase. We pull a wire from this point to deliver phase power to the door switch and then bulb. The neutral wire is also drawn from the plug, left, completing the wiring for the bulb. Now the bulb has both phase and neutral and will turn on properly when the door is opened. To operate, the compressor needs both phase and neutral supply. Since this is a single-phase compressor, we must correctly identify the 3 terminals: common, start, and run. Here's how. Use a multimeter set to resistance mode. Check resistance between all 3 terminals. You will observe the lowest resistance is between common and run. A slightly higher resistance is between common and start. The highest resistance is between start and run, sum of the other 2. So, terminal with lowest resistance, run. Slightly higher resistance, start. Terminal shared by both, common. Now connect the neutral wire to the common terminal via the overload protector. From the OLP, connect directly to the common terminal of the compressor. For the phase, draw phase wire from the plug and connect it to the thermostat. From the thermostat, take a wire to the relay. The relay has 3 terminals: common, start, and run. Now connect phase wire from the thermostat to relay's common. From the relay, 1 wire goes to the start terminal of the compressor. Another wire goes to the run terminal of the compressor. Also, connect the green earth wire from the plug to the metal body of the compressor for safety. In case of any leakage, electricity will pass to the ground, preventing electric shocks. When you plug in and switch on the refrigerator, power flows to the thermostat. If the inside temperature is higher than set, current flows through the thermostat relay, compressor. At this stage, the relay energizes both the start and run windings. Once the compressor starts, the relay disconnects the start winding. The compressor keeps working on the run winding alone. When the inside temperature drops to the desired level, the thermostat breaks the circuit, stopping the compressor. As the temperature rises again, the thermostat reconnects and the compressor starts up once more. If the compressor overheats, the overload protector disconnects the neutral, stopping the compressor. Once it cools down, the OLP resets and power is restored. So friends, now you've learned how fridge wiring works and how a refrigerator operates. If you enjoyed this video, don't forget to like, share, and comment.